Hello everyone. In this video, I'm going to explain what are context windows and how ChatGPT recalls things and sometimes forgets to. So you can think of context window as the working memory of the model, the amount of information which it can retain at a time while giving a response. So I want to give you a very relevant analogy. Like, for example, you are preparing for an exam and the examiner has allowed you to take a single sheet of paper with you in the examination and you don't know anything apart from the information which is present in that single sheet of paper. So that single sheet of paper is your context window. You don't know anything apart from it. The same thing applies with large language models. So you can think of large language models context window as the sheet size for their examination, and the examination here is the input which you have given and the output which you are expecting. So the context window is measured in tokens. So what are tokens? I have created a separate video for tokens. You can watch it in my YouTube channel. So tokens are basically the fundamental building blocks of large language models. Large language models don't understand text like we humans do. They understand tokens. And context window size is also measured in tokens. They are not measured in characters, words, or any other normal natural language terms. So let's give you an example. Like the weather is beautiful today. So here the weather is beautiful and today. There are 5 tokens present in this particular sentence. So if a model has 8K token context window, it can hold up to 6,000 words at a time and give response based on that. Yeah, there are information which is trained on the large language model, but I am talking about the extra information, which is the context window. Yeah. So don't get confused with the knowledge which a large language model already has and the context window which you are feeding. Both are different. Context window is the information which you are feeding. And when the LLM was trained, the information which it was trained on, it is a separate training set data. That is a different data. So there is a misconception that if we have 128K context window, we can put in 128K tokens of input and we can get unlimited output response. This is not the case. This is wrong. The total budget is shared. Like the input tokens and the output tokens together consume the same context window. So therefore, the input tokens and the output tokens, when both are summed up, should be always less than or equal to the context window. So why context window matters? So there are a couple of points. The first one is we can have a better conversation with large language models because there is no limit to the input token and the output token. It means you can talk longer with large language models. They retain more context together and their responses is much more better. Better document understanding. Like if you upload a large number of documents, it can retain all of them and refer to the entire document while giving a response. Like better agent performance. So agents perform better when the context window of a model is large enough to retain the tool calling features, retrieve documents, and retaining the user instructions. So all this consumes a lot of context, and a bigger context window is very helpful for agentic applications. Now comes what happens when the context fills up. So when the context window gets filled, the information which is present earlier is dropped off, and the new information is added. Like that's how the modern large language models are designed to. Like I want to give you a small example. Like let's say you message one, let's say there's a message one, message two, message three, and you are chatting with the large language model till message 100. Now the context window is completely filled. So when new messages are given to the large language model, those messages are inserted into the LLM, but the messages which are at the end, like the message one, message two, which are the earliest messages, they are stripped off and removed from the large language model in order to accommodate the new messages in the context window. That's how large language models are designed. And so there are a couple of problems. Like as I explained, there's a lost in the middle problem. And there's a very important insight that researchers who are researching on these large language models, they have found that the beginning of the context and the end of the context, those tokens are more emphasized by the large language models. They pay more attention to them. I'll explain you what is an attention in large language model in the upcoming submodules. So this problem is called lost in the middle. And remember this fact, that bigger context is not equal to better reasoning. This is a huge misconception. Like beginners assume that the more the context window, the better is the response quality. No, not at all. Maybe with the information, it is better, but the quality of response drops significantly when the context window is getting filled with time. If a model can see 1 million tokens, still can reason poorly. So there is no correlation between a huge context window and the model performance. They are both different things. A large context window ensures that the model retains a lot of information while giving a particular output, while a better reasoned model will reason on the limited information and the limited context window it is available with. It can reason on it in a much better way if the model is better at reasoning. So these are completely separate capabilities of a large language model. So instead of sending complete 500-page books, what you can do is apply RAG to large language models. I'll explain you what is RAG in the upcoming lessons. It's basically a kind of memory layer on the top of large language model, which helps a LLM to retrieve the relevant context and put in the context window to get the relevant output. So I'll explain what is a RAG. And if the context window of a model gets filled, this is one of the best solutions which you can apply in your organization or in your project workflow. The full form of RAG is retrieval augmented generation, and it basically fetches the relevant information which is required by the LLM for a particular response, so that the context window do not get filled again and again. What happens is present day large language models, they compress context and summarize them so that it can get space for the upcoming information which is fed to the LLM. So you must have used Cursor or any other AI application. When the context window gets filled, the model automatically triggers a summarization tool, which summarizes the entire context which it is having right now into a much smaller information block, so that it creates space for upcoming context to come in. As an AI engineer, you'll encounter context limits everywhere. That's the very basic problem which every AI engineer faces. You know what is the most difficult problem which is unsolved by the frontier AI labs? It is context window. If we have infinite context window, we can simply put the entire context to a large language model. We don't need to optimize what needs to be put, what need not to be put. We can simply put in the entire information. This doesn't happen. So the context window is the information which is present in front of large language model while it is generating a particular response. Now, context window is measured in tokens, not words. So input and output share the same token budget. So larger context helps with long conversations and large documents. So when context fills up, older information gets removed. Models often suffer from lost in the middle problem. Bigger context does not mean better reasoning. They are separate capabilities of large language models. Context costs time, compute, and money. So as an AI engineer, you must manage context for scalable applications. So in the next submodule, I'll explain you what is attention. Till then, stay tuned.